Hi everyone, I'm going to be going over the electron transport chain in ATP synthase, also chemiosmosis. Here, we know that these are our hydrogen pumps because they're transmembrane proteins going through the entire phospholipid bilayer. We know that this is ubiquinone because ubiquinone is fat-liking, meaning that it is in the hydrophobic region of our phospholipid bilayer. Here we know this is cytochrome C because it's water-liking and on the hydrophilic side. First step is NADH is oxidized by NADH hydrogenase and NAD plus is given off. When this happens, the oxidation of NADH reduces NADH hydrogenase and it is reduced with 2 electrons. When this happens, it allows the 10 hydrogens released when NADH is oxidized to be pumped through the hydrogen pumps as the electrons move along. 4 hydrogens are pumped through NADH hydrogenase. As the electrons move, 4 are pumped through BC1 complex, and 2 are pumped through cytochrome oxidase complex. Then oxygen accepts these electrons as the final electron acceptor in the electron transport chain, and it combines with hydrogens and metabolic water is made. Now we will look at FADH2 being oxidized to FAD. When this happens, FADH2 reduces ubiquinone, giving it 2 electrons. It powers the pumping of the 6 hydrogens that are released when FADH2 is oxidized. 4 hydrogens are pumped through BC1 complex, and 2 hydrogens are pumped through cytochrome C oxidase. These electrons, it goes through all cytochrome C, and these electrons are accepted by oxygen, and then water is made. As a recap, 2 electrons are given from NADH being oxidized, 2 electrons are given from FADH2 being oxidized, and they flow this way through ubiquinone, through cytochrome C, and accepted by oxygen. As a recap, we had 4 hydrogens come through NADH hydrogenase from NADH. We had 8 total come through BC1 complex, 4 from NADH and 4 from FADH2. We then had 2 come from NADH through cytochrome oxidase complex and 2 from FADH2, making it a total of 4. Now that we have these 16 hydrogens down here creating a proton modal force because they were pumped against their concentration gradient, this will power ATP synthase to make ATP. Okay, we have 4 hydrogens that can be pumped through ATP synthase at a time. 1, 2, 3, 4. The 4 hydrogens go into the rotor. As ATP synthase is phosphorylated right now, ADP joins it and it is dephosphorylated to release ATP. The 4 hydrogens come out and this continues. We have more than just one NADH coming in. We have more than just one FADH2 coming in, and this cycle just continues as these are coming in from the Krebs cycle.